What's going on? Louis here, bringing to you today the HM-3210, creating a Hex-Penta mesh using surfaces. Today we're going to be creating a hexes and pentas mesh using different functions and also going to be checking and fixing for the lack of connectivity in the mesh. So let's get down to it. First, I'm going to retrieve the arm bracket.hm model. Um, we're going to start by meshing this base. So I'll isolate this. So it's going to be the only component we'll see. Um, it is divided in two surfaces here at the top. And we're going to be using a approach in which we make a 2D mesh and then extrude that. So let's go to the 2D page, auto mesh, and then we're going to select the two surfaces, going to put it on automatic and leave the element size as 10 and the mesh type to quads only in mesh. This is what we get. And now we're gonna make the extrude, in which case in the 3D page we're gonna be using the element offset panel. So we're gonna be doing solid layers. We're going to select all of the elements, all of the displayed elements, and then here we're going to set the number of layers as 5, 25 for the total thickness, which is the thickness of this base, and then simply click offset plus. And now we have this mesh, this solid mesh of hexes and pentas for the base. Click return. Now what we want to do is go and mesh this curved arm. As you can see, it is also a surface geometry, but we're going to be using a different method for meshing this. First thing we're going to have to do in order to mesh this is to mask these hexes and pentas and leave only the shell elements that we have here at the top. So we're going to go to the mask panel and select elements by configuration. Select the hex 8 and then we click select entities and mask. Now we're going to return and show the arm curve. Not going to use this solid visualization, going to use the wireframe. Now what we're going to need is to pick these elements and spin them over this solid here, making kind of this 90 degrees arc. The way to do that is to pick these 2D elements and spin them around. But first we have to identify the center of rotation of these arcs. So to do that, we're going to go to the distance panel in the geom page, distance panel, the 3 nodes sub panel. With the N1 selector activated, we're going to click, hold, and pass over one of the arcs, and then when we see this square with a dot in the middle, we can release. And now it's only going to pick nodes in this arc, so we can left click for N1, N2, and N3, and then we click circle center, and the node which represents the circle center appears, and then we can return. Now we can go to the I'm gonna first make this arm curve the current component, and then on the 3D page we're going to the spin panel, spin element sub panel, to select the 2D elements that we want. We can select elements by geoms and then surfs and pick this surf. The geometry was not activated, and also going to hide the arm curve so that we can pick this surface and add to the selection. So now all these elements have been selected, and we're going to revolve around the x-axis, as you can see, and pick the base node as the circle center we created. It's a 90 degrees arc, and we're going to create 24 elements on this spin. So now we can click spin minus and turn on the elements, and we can see that we have a hexa mesh on this now. And click return back to the 3D page. The next step is to create 2D elements on this surface so that we can use another method for meshing the arm straight component. As you can see, it is a tapered section, so we're going to use another method. So we're going to go to the tool page, and then faces panel, going to select the arm curve component and set a lower tolerance for this, and find faces. And HyperMesh creates a component called faces, which holds all of the shell elements on the free faces of these 3D elements of the original arm curve component. Now we can return and move on to the arm straight component. So I'm gonna make this current. Going to mesh these opposite faces first. So back to the panel, auto mesh, 2D page auto mesh panel. We're going to select these surfaces. Going to put it in interactive mode and click mesh. What we have to do here is to mesh exactly the number of nodes or elements on each of these edges. So we can see that this edge has 3 elements, so I'm gonna crank it up to 3, and also these ones. This edge right here has 4 elements, and this one also has 4. This one here has 4, but in here we have 3, so I'm gonna make it 4. And just checking this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in here, and 10 elements in here. So we can mesh. Oh, apparently we have forgotten this one. So make it 4, and then mesh again. And now it looks good. I'm going to return and then move on to the solid meshing now. So in the 3D page, I'm going to now use the linear solid panel. The front elements on this face. So select this element and then by face. So it chooses all of them and 2 elements. I'm going to select one on this face and pick by face. And we also have to set the alignment nodes so that HyperMesh can know how to make this interpolation from here to here. So just pick any same nodes on the 2 elements that you have on each surface. So as you can see, they are matching edge for edge, node for node, and I'm going to set the density of the distribution layers to 12 on this and click solids, and there we have it. And we can return. We're going to move on now to the last component, which is the boss. This is what it looks like. So I'll call this surface the bottom and this the top one. We're going to start by meshing the bottom surface. So go to the 2D page, Auto Mesh panel. I'm going to turn this to the solid visualization mode. It will be easier to select these surfaces. And click Mesh. Going to reset the edge density on these edges so that it can match the number of elements and nodes on this component. So I'm gonna make 4 in here and also 4 in here. In order to make a radial mesh, I'm going to have the same number of elements on the inside hole, on the inside circle too. So I'm going to move it 4 in here, also 4 in here, 4 in here, and here. And since it has 15 here, going to move on to 15. And freeze on the radio position, and we can mesh, and it looks good. So we can return and return again. Next thing we have to do is to project this node, this rightmost top node on this line. So the way to do that is to go to the 2 page and project panel. We're going to be projecting 2 line, and the node we want to project is this one. Going to first duplicate it and 2 line list. We want it to this line and along the x-axis, which is this one. So we're going to click project, and there we have it. Can return, and now we can move on to the solid meshing. Indeed. So in the 3D page, we're going to use now the solid map panel and the general sub panel. Going to set the source geometry to none. The destination geometry is going to be the top surface, and along geometry we're going to select mixed. For lines, we can select this line or any other vertical line we have in here, and to select a node path we're going to be selecting the nodes from top down. So I'll start with this one and then go along this line. So we have picked all of the nodes. Now we have to select the elements to drag, and we're going to select it by collector and pick the boss and select. I'm going to leave the element size as 10 and click mesh. And as we have forgotten to set the boss as the current component, HyperMesh has created another component in which to set the elements that we have created, but we can move these elements back to the boss component. So I'm going to turn the elements on the boss on. I'm going to go to the organize panel and going to send the elements from the solid map collector to the destination component, which is going to be the boss. So move, and it's done. And now this is a empty component that we can delete. And now the last thing we have to do, going to turn the elements back on in here. The last thing we have to do is to check for the connectivity of this entire model. So anywhere that we have transitions from one mesh to another, as we have meshed different components, we have to check the connectivity to make sure that each node is matched on each component. So I'm going to first actually delete these faces here. We're not going to use it anymore. Now in order to check the connectivity, we're going to go to the tool page and faces component. We're going to select all of the components and find faces. So it's going to create a new faces component. And what we want to do here is to go to the post page now, create a hidden line, which is going to be on the XZ plane, and also going to check for trim planes, which is what we want. And we can show this. I'm going to hide all of the other components. We're just interested in seeing the faces in here. So going to show, and you can click on this and drag along to see the inside of these shells. So as you can see here, we should not have this wall of elements in here, because it indicates that it has a gap between the solid elements on the boss and on the arm. So what we want to do here is to make an equivalence of nodes. So we're going to return, and to make this node equivalence, we're going to go back to the tool page, faces panel, and we're going to increase the tolerance. The way you would do that is to increase the tolerance by, say, tenfold, and preview the equivalence. Sorry, forgot to pick up the faces elements, and then preview the equivalence. So it has found 7 nodes. The status bar displays it has found 7 nodes that could be equivalenced, and it shows it in here. But obviously we have many more nodes along this L-shaped connection, and also in this L-shaped connection. So I'm going to increase it by some more and preview it again. Now we have many more nodes. It looks like almost all of them. Just going to increase it a little more to check. So it's at 53. Now has found 60. And going to increase it a little more. Preview again, and it looks like this is it. We have 60 nodes in here that need to be equivalenced. So going to click this equivalence button, and it says that 60 nodes were equivalenced. And now what we should see in here is a open connection when we make the hidden line. So it should be one entire hollow body, if you will. So back to the hidden line panel, going to show it again. Now, one thing to notice is that it didn't work, but actually it did work. Just go back to the tool page and then faces again and compute the faces component once more. Find the faces, and it should be right this time. So if you drag along, now you can see that it has made the transition and it works like a hollow body. You could also check the connectivity on the other surfaces, like the one on this part of the L-shaped. So click and drag again, and you can see that it is all hollow in this faces component. So this means that all of our 3D elements are connected and are ready for an analysis. So right now we would be able to delete this faces component and show all of the connected components that we originally had. So this is it for today, guys. A little longer one because of the number of components. I hope you have enjoyed it. If you have learned something, leave your thumbs up and remember to subscribe, hit the bell, stay tuned. I'll see you in the next one.